Hello everyone, this is Kieran Patel working as assistant professor in Computer Science and Engineering Department, BLDAC 3 Vijaypura. Now, friends, we have looked our first transformation, which was the translation. Translation means nothing but to move a point from certain position to some other position. Now, we shall look into what do we mean by a scaling. Generally, scaling means to enlarge the size of an object or to shrink as the size of an object. Alright. Now, to alter the size of an object, we apply a scaling transformation. That's what I mean. Either you can enlarge the size of the object or you can shrink the size of the object. A simple two-dimensional scaling operation is performed by multiplying object position, that is x comma y, by the scaling factors sx and sy to produce the transformed coordinates x dash and y dash. So basically it means x dash is nothing but the product of x and sx, and y dash is nothing but the product of y and sy. Scaling factors: Sx scales an object in the x direction while Sy scales in the y direction. That means these are the scaling factors in the x-axis as well as the y-axis. The basic two-dimensional scaling equation, that is number 10, can also be written in the following matrix format. That is, x dash y dash is equal to sx0 0 sy into sy. Now if you perform the calculation on this particular equation, so you will arrive at the equation that is given above. So basically it means p dash is nothing but s dot p, where p dash is the transformed points, s is nothing but the scaling matrix, p is nothing but the original points. Okay. Now, so you can see an example here. We have an object, okay, which more or less looks like a square object. All right. And then if I apply the scaling on it, for example, turning a square into a rectangle with the scaling factor sx is equal to 2 and sy is equal to 1. That means I'm doubling the size towards the x direction and I'm keeping the y as same as the original one. So that means you will arrive at the object that looks exactly in the figure number B. That means you have transformed a square object into a rectangle by applying scaling, that is sx is equal to 2 and sy is equal to 1. Now similarly you can also see an example here. We have an object, we have a line, in fact we have this line, and what we do is a line scaled in with equation 12 using sx and sy is equal to 0.5 is reduced in size and move closer to the coordinate origin. So this is very evident from the figure itself, right? So what I'm doing is I'm taking a line, I'm reducing its size in both the direction, that is in x as well as the y direction. So you can see the resulting line is smaller in size and has moved a bit closer to the coordinate origin. Alright, now we have seen the transformations such as translation, we have seen the transformations such as scaling. Now it's time to know about rotation. Right. Now before we go into the concept of rotation, let us just refresh our mathematical knowledge, in fact, geometric knowledge, right? Now, this is an angle theta, an angle theta. The side opposite to that angle is called as the opposite side. The side which is, you know, which is adjacent to the angle is called as the adjacent side, and this side is called as the hypotenuse. Okay, I want you to remember this basic knowledge, right? There is an angle theta, there is an opposite side, there is an adjacent side, and then there is the hypotenuse. All right. So basically, you can see from this figure, right? It is similar to the figure that was given in the earlier slide. Okay. Now from this, okay, so from this, okay, the rotation is to be defined. Okay. Now, rotation of an object through angle theta about the pivot point xr comma yr. You can see he has taken a reference point over here, which is defined by the points xr and yr. Now this is the reference point. Okay. Now from this point you are supposed to rotate the geometric object. It may be a polygon, it may be a simple point, or it may be a line or whatever, right? Alright, so let us look at this figure here. Now in this figure he has given a line segment, or a point, in fact. Okay, the original point is defined with the values x comma y. Rotation of a point from the position x comma y to the position x dash comma y dash through an angle theta relative to the coordinate origin. The original angular displacement of the point from the x-axis is phi. Yeah, so basically what it says, that there is an point here which is defined with the values x comma y. Now this point, our objective, let us understand this, our objective is to rotate this point to a new position defined with new values of x and y, that is x dash comma y dash. So the angular displacement of this point is treated as theta, and the original angle made by this point with respect to the x-axis is phi, right? And this, we take it as, this distance is termed as r, right? So have you understood? Now there is a point which is defined with the values of x comma y, and that point has to be moved to a position x dash comma y dash with an angular rotation of theta. The point makes its original angle with the x-axis as phi. The distance between the coordinate origin and the rotated point is termed as r. Now that r is also is also the same for the original point with respect to the coordinate origin. Now here, which is the reference point here, my dear friends? The reference point here is the origin of the coordinate. Alright. Now, let us look at the equation here. X dash is equal to r cos phi plus theta. Okay, according to cos of theta plus 1, it could be written as r cos phi cos theta minus r sin phi sin theta. And y dash is equal to r sin phi plus theta, according to the trigger, the extension of this. Sin theta plus theta 1 would be extended as r cos phi into sine theta plus r sin phi into cos theta. Now, how did we come to this conclusion of equation number 4? Equation number 4. For that, we need to go back to the slide, right? Now here you can see that, okay, the cos of theta so cos theta is equal to, what is cos of theta? Cos of theta is equal to, anybody who knows the equation for cos theta? Alright, let me tell you, cos of theta is nothing but it is adjacent side divided by the hypotenuse. Now, so that adjacent phi, cos of theta, we are talking about the rotated point x dash comma y dash. The total angle made by that particular point with respect to the x-axis would be theta plus phi. So, cos of theta plus phi is equal to, what is the adjacent side here? It is x dash divided by r. That is the hypotenuse. You understanding now? Alright. Now what happens? So x dash is equal to r into cos of theta plus phi. Right. So that's what is depicted in the next equation here. X dash is equal to r into cos of phi plus theta. So which makes it r cos phi into cos theta minus r sin phi into sin theta. Similarly, y dash is equal to, again, sine of theta is nothing but the opposite divided by the hypotenuse. Hypotenuse is r, opposite is y dash. So y dash is equal to r into cos of the angle. So what is the total angle made there? The total angle made is theta plus phi. So that is y dash is equal to r into sine of theta plus phi. All we have done is we have extended this particular equation using the formula for sine of theta 1 plus theta 2. So that makes it r cos phi into sine theta, r sine phi into cos theta. The original coordinates of the point in the polar coordinates are again the same, the same formula has to be applied. Now take the original point, which is defined with x comma y, and if you are supposed to calculate again the cos theta, cos of phi in this case, okay, so that would be adjacent by hypotenuse. Adjacent is x in this case, hypotenuse is r. So x is equal to r into cos phi. Similarly, y is equal to r into sin phi. Now if I replace this r cos phi and r sin phi with x and y respectively in the equation number 4, then our equation would be turned into x dash is equal to x cos theta minus y sin theta, y dash is equal to x sin theta plus y cos theta. And hence p dash is equal to r into p, where r is nothing but the rotational matrix, which is cos theta minus sin theta, and cos theta. Alright. Now what if the reference point is different? Okay, now previous example, the reference point was the it was the coordinate origin. Okay, what if it is different? Okay, what if it is other than the origin? What if it is xr and yr? Then how will the equation change? Let us see. Okay, in that case, x dash is equal to xr plus x minus xr into cos theta minus y minus yr into sin theta. Similarly, y dash is equal to yr plus x y dash is equal to yr plus x minus xr sin theta plus y minus yr cos theta. Alright, friends. So I hope that you have understood the two more transformations, that is scaling and rotation. Alright. So if you like this video, please like this. Please hit the like button and support me. Keep supporting me. Keep loving me. Thank you all. Thank you very much. Good night.